Okay, so I'm going to teach or make this tutorial for HEC RAS 5, which is two-dimensional modeling for hydraulic problems. And in HEC RAS 5, you can do two-dimensional modeling. You can get floodplain and other different parameters for hydraulic modeling. I will start from creating a new project and saving it to tutorial. Click OK and click OK here. I will open RAS Mapper. I will create a new terrain. I will say no because my raster file has projection in it. As you can see here, the raster file has a projection. I will say yes and create terrain. I will wait for it. So the terrain is created now. I close this dialog and double click on it. Sometimes it doesn't show, so zoom to layer. You can do like that. So I will save my project, go to geometric data. Now I can see my domain. There are many different tabs and options. You can give many input file as geometric data or Manning coefficients. You can give Manning coefficients like this from here, and you can define many bridges, culverts, inline structures, lateral structures, storage area like reservoirs, and connections between storage area and 2D area connections. For example, 2D area flow. For example, I will start by making I will start with just first of all set your geometric extents. You can pan your map by using shift button. Okay, if you shift it, I will give cross section from here as a flow hydrograph there. I will create the domain by clicking to the points. I'll follow the elevations here. This is downstream of my study area. Okay. You can create 2D flow area based on your computational resources, computer resources. For example, if you have a faster computer with a good processor, you can give bigger area. Also, it depends on the flow rates that you want to give. So if I double click here and say, let's say to the flow area, if I click OK, it will connect it to the starting point. I will remove this point, and you can remove it by using these tools. And I will move these points to here so that it could be in this string. I will click here, so I will disable editing. Then I have to find the computational points. You see, we go here and give delta x and delta y. I give 20 feet to 20 feet and generate points. Now the cells are computed actually. Now if I click OK, it will create my mesh, as you can see here. Okay, so in here we have, before doing anything, just save it, geometry. We have some points that 5 phase errors detected on the perimeter of the mesh. Okay, now I have to edit them and remove them first of all. Then I have to move my mesh a little bit more, or maybe like this. So now I can force computation. I have to remove these points. If you get these points, maybe you can remove them at first and don't do the computation again for mesh. Okay, so now it created my mesh and there is no problem in my mesh. Okay, mesh computation, that's okay now. Okay, so I lost my DEM file, DEM at the background. I have to bring it. I have to go and export as image and call it map. I save it. Okay, I saved it. Now I have to add map layers. Go to images and select it. Now I can go to geometric data and select map and see what is what and where is where. So now, yeah, I have to define two boundary conditions at upstream and downstream. If you don't define a boundary condition at the downstream, it will be a storage area and it will store all of the water that is flowing from upstream at the downstream. So boundary condition, I will double click at the second point and say upstream boundary condition. I click OK. Now I zoom out and go to downstream. Okay. Now I click on boundary condition, and actually you can, if you have flow data at one cross section, so try to move these points until you make them perpendicular to the cross section, that cross section. So it's nearly, I think it's okay now. So after that you have to check it. Okay, so when you edit your mesh, edit your 2D flow area, you have to again compute the mesh. So I will zoom out. It automatically did it. So there's upstream, and now we can give the downstream boundary condition. I click here and double click here, and I will say downstream EC boundary condition. That's it. I will save my geometry data and zoom out. Okay, you can remove your map from here, background map, or you can add it as you wish. So save, close. Now it's time to give the flow data. Unsteady. I go to unsteady flow data. We can see the boundary conditions here, boundary lines. And first of all, we have to, it depends on your preference, either way it works. So I go to flow hydrograph. I will give hydrograph that I got from USGS. It's for another stream, but I'll use and test how it works for this one. Press End, hold Shift and press arrow button to the down and Control C. I click here, select all of that column and Control V. I will click OK. Then go back again to see that the number of the ordinates are updated. So I will give the start of my data is from 29th of March. 29th March 15. The interval of the data is 1 day. Okay, now we can give minimum flow rate and multiplier as a so it would multiply the ordinates of the flow to that number that you give here, and here it's the energy slope, as you can see. So I click OK. We don't have anything to do now. It's finished now. That's all. Now we have to go to downstream boundary condition, and I will say it's normal depth, the variation slope of 0.01. Now we have to save our unsteady flow data. I will say yes. I will go unsteady. Okay. So I clicked open, that's why. Okay. So initial conditions are optional, as you can see here. I don't give anything to them. We can view the data by plotting the data. As you can see, there are more fluctuations, and sometimes there is no flow. Actually, I added 0.2 to this flow rate when I got it from USGS stream flow data. So I can see the flow rates. You can add any flow rate you want, so this is only for test. I will click on project save. Now we have tutorial, geometry, and unsteady flow data. Now we have to have a plan for our run. We will go, since we have given the unsteady flow data, we have to do unsteady flow analysis. We go to run unsteady flow analysis and click it. Now we first set a plan, call it plan A. I click OK, and the short ID could be a digit or character. So this is my first run, so I will click 1 and I will press 1 as an identifier for the run simulation. I will say 1, and this is geometry preprocessor. If you click it, it will get the elevation data for each grid cell, located in the domain. So it will get the data, and post processor flood plane mapping. So I will come here and starting time I will say March 29. The data is for 1 year. As I said, you can change your data. I'm just testing. So here I will select 6 hours as the output, hydrograph interval, and detailed output interval, and computational interval. So I will save it. So geometry preprocessor, what it does is just coming here and right clicking on it, compute 2D flow area hydraulic tables. That's what it does. When we check it, it will do this and assign the values and find the tables, property tables for 2D cells. Okay, now we have to save it and go to run and unsteady flow analysis. As we have already saved it, you can see that. Now we have to press button compute. But before that, we have to go to options and calculation options and tolerances. Go to 2D flow options. From here you can select your equation sets. For each of the 2D flow area, you can select different one of these two equation sets, full momentum and diffusion rate. It depends on your preference, so you can give more, you can change them, modify these values based on your needs. So I will give 48 hours. This is an hours, and this is called actually warm-up. For every modeling program, when we are doing simulation, we have to give some time for the model to warm up and give more dependable results. Actually, if you have given initial conditions from a previous simulation run, you don't need that. So because I didn't give any initial conditions, I have to do that. Now I have to click OK and save plan again. Now everything seems okay now. I click compute. Yeah, upstream boundary condition says time series data starts after the simulation starts. Yes. So I will say 13th of March. Oh yeah, I forgot to change the date. also 2015, 28. Okay, now save and now compute. Any time of simulation needs to be active. Let's check our data. I forgot the. Okay, so here simulation time window 29th of March. Okay, anytime it is, yeah, I gave it wrong, so let's give it 26 March. Okay, now we are sure that the plan is right and the time and dates are right. We have to save the project again and compute. Oh yeah, I forgot to give it. I'm sorry. Let's give it like that. So save. So be careful of these two. I mean dates. Actually, we could do something else. It could make easier. Just tell that use simulation time. It would be very easier for us. So I just wanted to give you data as they are. So I will compute. It will start the computation. There are different processes that it does. So writing geometry, 2D flow area, mesh property tables are current. If I didn't go to RAS mapper and compute property tables, it will also compute it here and complete writing geometry. That's the geometry preprocessor. You have to recheck it. I think I recommend it. So it finished and writing event conditions and performing the flow simulation. Now, and yeah, the iterations of 20 and this cell 8063, it has some errors. Okay, you can check it. You can check that cell if you want. You can change it. Maybe it's because of the cell size. So here you can see the iteration numbers for each of the dates. It will do some iterations, and so the process is complete, and now you can close it and close this one. For viewing our results, we have to go to RAS mapper, open it, and okay, now also we can disable this one and generate layers. Okay, so if you we can generate layers from the cross sections that we gave and use them here, but since this is only 2D, if we want to give 1D river reaches and cross sections, flow passes, you have to define all of them. I will create another tutorial in the next future to show you how to create cross sections and flow paths and the other input geometry data for HEC RAS using QGIS. So okay, so we have the results here. We can see the depth. This is the maximum depth actually. Why? Because it says maximum here. That's very simple. Okay, so if we want to animate it, we can click here. We can give some animation delay for delaying the frames, each frame. So we can click on play, and yeah, as you can see, the flood plane and flow rates. Flow is how it behaves, and you can see the elevation by just pointing to the one point. As I said, the data are so discrete, the flow data. I mean, and there is the interval of the data are very coarse, so you can change it with a good hydrograph and define it at the upstream boundary condition. Also, you can come here and see how the velocity changes. Highlight it first, then go back and animate it. You can animate and see where it's maximum and minimum. So velocity, I don't know, maybe because it says it's 0. So you can also find the water surface elevations. It will show you the changes. Okay. So I will pause it. So you can also export the data here to database and use them as database and edit them, post-process them in ArcGIS, but you have to delete these underlines. Minimum and maximum and profiles, you can create it and save it wherever you want. And so this is the very brief tutorial and very simple one to show you how to use HEC RAS 2D, and I hope that you enjoyed it and it could be useful for you in later times. So thank you for watching. Thank you very much.